Knowing about continuous variables, we are now set to talk about the normal distribution. Let me introduce the normal distribution this way. You have 30,000 samples from a binomial distribution. Now, a binomial distribution, remember, is discrete, which means you can only have specific values, right? A normal distribution looks a lot like a binomial distribution, but it's a continuous variable. So for example, on the left here, I have 30,000 samples from a binomial distribution, but on the right, I have 30,000 samples from a normal distribution. They look fairly similar. But remember that with a normal distribution, I'm looking at a range of numbers. So each bin in my histogram is looking at a range of numbers. If I cut each of those bins in half, and then half again, and then half again, I can keep going for a long time until I have infinitesimally small bins. The height no longer represents the probability. It is now part of the density function, which I'm indicating with the line that's drawn on the normal distribution graph here. And how do I find probability then? Instead of finding the height of a single bar, we're going to find the area of multiple bars. So we find probability by using the area. So how are we going to do that? I mean, last video I showed you how to find the probability of a uniform distribution. Just take the height of your density function, multiply it by the width, and you've got the area. That's nice because it was a nice rectangle. But in this case, it's not an easy area to calculate. In order to find the area, we need calculus. Now, some of you probably just started to panic as soon as I said that. Please don't, because, well, it's been done for us already, okay? People have used calculus to find the probabilities and then given that to us for us to use. We have a number of tools that we'll use to help us calculate the probabilities. Your TI-84s will do it. I have videos at the bottom of this page that will show you how to calculate probabilities using a TI-84. We also have a physical table, a piece of paper with a table on it that will help us find the probabilities as well. We have other tools like Desmos. Let me show this to you on Desmos, and then we'll go for that. So here is a simple normal distribution. Let me get rid of that for a second. Here's a simple normal distribution. And couple of things that I want you to note first. Remember that if we have everybody in our sample is positive for whatever we're testing for, that is 100% of our sample, right? So in theory, what's the probability then of selecting somebody who fits in a category? If everybody fits in that category already, should be 100%. Here's my point in saying that. If I take the area of this entire curve, what is my area? Well, the area between negative infinity, that's the far left tail of the curve, and my value A, which is far right end of this curve, is 1. Now, I have this approximated. If I go to a much larger number, then this will be exactly 1. There we go. The area under the entire curve is 1. That's why the normal distribution is so useful for us in statistics, is because then the area under this curve represents 100% of the population. Now, let me do another example. If I say, well, let's cut it in the middle, I'm going to set this value to 0. What is the probability of selecting somebody that is less than 0? Well, that is half of my graph. So that's 50% right here, okay? 50% of the area is left of the graph, 50% is to the right of the graph. Now, I could pick any value. For example, A is equal to -1. What's the probability of a value less than -1? It is 15.9%, 0.15865 if you want to be exact. Okay, what's the probability of having a value less than 2? Less than 2, that would be the shaded region here. That probability is just the area, 97.7%. And I can flip this around. I can say, well, what's the probability of a value greater than that value? So probability greater than 2 is going to be 0.023, 2.3%. What's the probability of being greater than 1 or greater than 0? That's going to be 50%. That's half of my graph. What's the probability of having a value greater than -1? That'd be 8.41. Excuse me, 0.841. I said that improperly. I apologize. Okay. So we have calculators that will find the area for us. In the next video, we're going to talk a little bit more about some of the other things we can do about finding probabilities in a normal distribution.